Welcome. Male markers. In the former video, I talk about male groups and female groups in order to try and make things a bit more understandable or natural. Perhaps it would have been better if I had called them male markers and women markers. This way Y-DNA haplogroup R would become male marker R. And it would have been better if I had called the male marker R as the Western European marker, and as the Western Eurasian marker. Since this above, haplo, group or marker is about modern humans in the so-called developed world, I could give it more context, by calling it the developed world marker and in certain context also the colonization marker, conquistador marker. I suppose that at least some people interpreted these two markers as A. Female, feminine, and B. Male. Or alternatively women and men. But in fact, these two markers have little or nothing to do with A. Female or feminine, and B. Male. I will explain better below. I suppose that for many the use, mainly by consensus, of these markers, probably added credibility and is interpreted as credibility to the results of research, early science and most of all consensus, hypotheses, like for instance out of Africa. I think that most people do not really understand the marker-related information they get, but rather have the impression it is all very serious, and kind of conclude that it consequently must be right. Besides, it led to a convenient situation, because for lay people it looks kind of too technical and kind of obsolete to even try to look further into it. That was probably my own case for almost 60 years. Here I will try to A. Actualize, humanize, and simplify the whole subject, act. B. Make the subject a bit more informative and graphical. Separate and point out what is not what we think it is. Mitochondrial or mtDNA myth. For starters, technically, mtDNA is nothing female or feminine at all, in fact it is bacterial DNA. Please see presentation. Bacteria present, or have, no females and no males. As such, mtDNA has nothing female or male about it. mtDNA is also not part of the fertilization. mtDNA from the female egg cell and one or more male sperms kind of jump in the fertilized egg for the ride, they kind of hack the fertilized animal and human egg cell, but next the male mtDNA is eliminated, at least in most cases or most of it. However, a very limited amount of children will live their lives with mtDNA of their father in all of their billions of cells, instead of the mtDNA of their mother. As a result, it looks like that normally the mothers, or the women, pass on the mtDNA to the fertilized egg cell, and that is all. As said, there is nothing female or feminine to the bacterial DNA or genome that we call by many names, including mtDNA. Resuming, normally the fertilized egg cell that is located in the uterus of the female body eliminates the mtDNA that came from the male partner, from his sperm cell or sperm cells. So all male cells carry the mtDNA just as all women's cells carry the mtDNA. It is not something that only women carry. As a comparison, women carry all fetuses. That does not mean all fetuses are female. The situation of a fetus is only a bit similar to mtDNA. Women pass on to their offspring both male, from their father, and female, from their mother, DNA, and on top of that the bacterial DNA, that is extremely important for life and health, energy production, for both women and men. Most diseases have a mitochondrial or a bacterial DNA disorder component. That is how important mtDNA is for both women and men. Thank you for watching.